All right, welcome everybody. We're here today. This session is on production-ready infrastructure as code, or IaC. I'm going to take you through a couple of the trials and tribulations we've had in applying infrastructure as code to some major financial institutions, taking the lessons learned from us and what we experienced, right? What went well for us, what didn't go so well. I'm going to talk a little bit about that today. My name is Jeff Ardilio. I'm with KPMG out of our digital enablement group. Some of you might be asking, why is KPMG here, right? It's kind of a funny story. Over the last several years, I got asked that a lot. But if you look outside, you look at all the vendors in the expo, right? There's a lot of different product companies here. But that's not us. That's not what we do. We're not a product company. Instead, we're a solutions provider, right? We provide services and solutions that may integrate several of these different products. How do we take all of these different products, these varying pieces, how do we put them all together to have a cohesive workflow? How do we enable these transformations in modern delivery? And to us, we kind of coined modern delivery as something that takes on the principles of Agile, right? DevOps, security. How do we take all of these bits and pieces, even design thinking, right? How do we take all these bits and pieces and incorporate it with the people and change element to execute on these transformations, these major business transformations, right? So that's what we do. So with all that out of the way, what were we able to achieve? What are we going to talk about today? And I'll kind of center it around a case study of a recent client that we've worked with. And with that client, we were able to take a small team. We've got three engineers. Those 3 engineers were able to effectively manage and create 7,000 different infrastructure resources over 7 different environments, okay? These environments I'm talking about, these 7 different environments, these are non-production environments. They're also production environments. They're environments in multiple regions of a cloud provider. I've got them in the East. I got them in the West, Central. This is all, as I said, this was done with a firm in the financial services sector, right? And all the baggage and the scrutiny that comes along with doing that, and there's a lot of it. So how are we able to do this? 7,000 resources, just think about that a minute, right? That's a lot of stuff. These are VPCs that we need to create. Those are security groups within those VPCs. There's, we've got VMs that got to run against those security groups. We've got peering connections to all these different shared services, right? All these different things, the security angle that we need to manage. How do we do that, with just 3 people? We wouldn't have been able to do it if it wasn't for infrastructure as code, or it would have surely taken a lot more effort and a lot more people, a lot more hands to get involved in that. So taking a step back, for starters, let's just kind of level set, right? What is infrastructure as code? What are we talking about today? Infrastructure as code, or IaC, is a declarative model for defining what our infrastructure is going to look like. I mentioned before, I've got VPCs, I've got VMs that are going to run in those, I've got network connections I need to manage, right? All of these things in a declarative model that's human readable. People can read this stuff. I can load up all of my configurations. I can share and extract bits and pieces of my configurations with other projects and other teams, and I can have people review those changes. So why is this all important to us, right? Well, for starters, managing infrastructure, let alone 7,000 different little bits and pieces of infrastructure, it takes a lot of time and effort to do that manually, right? Not only does it take time, but it's prone to mistakes, and those mistakes lead to drift. Nobody's immune to this. We've all experienced it, right? If I have to manually manage infrastructure across 7 different environments, I'm prone to make a mistake at some point, whether I fat finger something or I copy and paste wrong. I don't follow the exact same procedure exactly between those environments. It leads to drift. Now I'm spending time within those environments trying to chase down these one-off errors, right? Why is this one issue occurring in this one environment? What's different about this environment versus the other environments, right? How can infrastructure as code help me to standardize that process and enforce that each of these environments are the same and propagate those changes throughout each of those environments? So I mentioned that we're talking about financial services here, right, for an institution. This may not be the case for everybody, but things like our audit procedure, our tech risk, they're highly scrutinized, and it's very important to us, right? We need to have a way to easily review our infrastructure and how it's going to be deployed so that tech risk can get involved, security can get involved, internal audit can get involved. How do we handle that, and how do we share that information with them, right? This declarative model that we're talking about at this point, it's human readable. I can now start to train and identify with different team members, whether it's tech risk, to actually understand the changes I'm proposing and what I'm putting through the flow so that they're confident in giving me approval to seek those changes out, right? That's really a big shift in terms of how we start to look at things. I think traditionally in a lot of organizations I worked with, when I'm laying out the infrastructure, they may be involved early in a design concept, and that design concept is somewhere in a wiki we put together what we're going to build, what we're going to design and implement against, right? And then maybe they're involved later on down the road when we actually built that, and now they're trying to review what we actually built and what's actually running against that plan, right? This shifts the focus a lot. Now they're involved earlier in the planning process around, what are the requirements going into this and how is it going to be built? But they're also involved, like in our case, during the review process and the pull request. If they're going to feed us the requirements for the specifications from a security standpoint that we need to adhere to, and they give us the acceptance criteria for that in our backlog, well, they can actually now look at that in terms of our pull request and accept that and acknowledge it against the acceptance criteria that they gave us. So another point that I want to make here is, I mentioned we have 7 environments. I don't know about you guys, but it seems like it's a never-ending task. Everybody's asking for a new environment to stand up, right? How do we do this in a repeatable manner? How do we make this more easily to stand up all these requested environments? And inevitably, something is going to go wrong, right? I need a way to handle some amount of disaster recovery within these environments. How can I restore the state of that environment against that expected plan? I'll kind of give you guys an example of something that happened to us recently. This was a couple of months back, right? Now, one morning I wake up, it's Saturday morning, I get a call about some sort of outage, right? There's a connectivity issue in one of our environments. Luckily, it was just one of the lower environments. It was one of our non-prods. Now, when I got that call and I'm looking into it, right? I could have spent a whole lot of time debugging. I could have gone through maybe my event logs in the system. I could have gone through the console. I could have gone through all these different means to start debugging, like what's the problem? Or maybe I'm manually trying to compare what's going on against what was in that outdated wiki we talked about before that we didn't keep up to spec. Instead, the first thing I did was, well, let me just give this a shot in the dark. Maybe something's awry. Let me just rerun the plan for my infrastructure as code and see if there's some sort of delta, right? Sure enough, I run that, and within a minute, the plan tells me, hey, I need to add these 2 security groups that seem to be missing, and these security group rules that seem to be missing. It's kind of funny. I'm like, why are these missing to begin with? But all right, let me give it a second. Let me just rerun the plan and see. Run the plan, it executes, it adds those security group rules back. Boom, within seconds, we've restored connectivity. Everybody's happy. Now, you're probably going to look at me and say, well, Jeff, if you've got this great infrastructure as code, why did you have this issue in the first place? Why were those security groups missing? Isn't that the configuration drift? And it's a really good question for us. Looking at, before I had time to diagnose where did those security groups go, those rules go, what happened, how did this come to be? Within a minute, they were gone again. I verified it. We lost connectivity again. I run the plan. It wants to add them back again. Turns out somebody has, I don't know if anybody's used these auto remediation security scripts. One of our clients their team happened to be running Security Monkey in the background. Well, Security Monkey had gone amok and had some bad requests, and it would go through and find our security group and just wipe out all the rules. And that was running on a continuous basis every 30 seconds. So we shut that down, restore our plan, reapply, and we're back up and running, right? But the point I want to stress is, I didn't spend a whole lot of time debugging. I didn't have to do anything. The system did it for me. It compared the system state, what is the expected state against what is the current state, showed me the delta in terms of a plan, and I can then apply that plan and restore connectivity. So how do we do this? How do we start to implement infrastructure as code? What do we need to consider? The first thing that we need to think about is how we view our infrastructure. And by that I mean, this whole, I don't know if anybody's heard it, the pets versus cattle analogy, right? So we need to start looking at it in terms of, like, if I think about pets in our traditional architecture and our infrastructure, we treat them like pets, and we really love and nurture our pets. And by the way, this whole analogy between cats and, or the pets and cattle doesn't work so well with my wife. She loves cows, so we'll work with the analogy we have for right now, but let me go with this. So we really love our pets. We dress them up, we name them. They mean a lot to us. We nurture them through their lives, right? And we sorely miss them when they're lost. We kind of treated infrastructure the same way, right? We did everything in our power to nurture that server, to keep it running, to prevent it from going down, right? We used to measure uptime of a service by how long that server was running without requiring a reboot or a restart, right? What if we start thinking about infrastructure more like cattle, right? It's one in a line. It's something that's replaceable. If one goes down, the rest can take on the load for a short term until I bring on another one on board, right? We start thinking about our infrastructure the same way. And I think with the way the industry is going with containerization and virtual machines and such, we've been able to leverage a lot of that and think about infrastructure as becoming more disposable. Within one of our current project that this reference case that we're talking about right now, we're running containers, right? Those containers run on VMs. The containers are destroyed and recreated on each app deployment. Those are happening multiple times per day. Those containers are running on VMs. Those VMs are actually destroyed and recreated on a weekly basis, where we do so in a canary rollout that involves zero downtime. And we do all this because it actually satisfies our tech risks appetite to have short time to live of each of these devices and these resources. And this allows us to do that. So what does it take to do this, right? It comes down to three basic pieces, right? We've got people, we've got tools, and we've got process. And everybody's going to get hung up on the tools, right? There's a lot of tools out there. There's a lot of great tools. You look out at the expo, right? We've got a lot of great vendors out there with great products. And I don't want to de-emphasize the tools. The tools are a means. But we have to have our people and our process aligned to execute on these tools and the best practices to put those forward to make them effective. We need to put the processes together to make a holistic solution. So that's what I'm going to talk about today. I'm going to talk about tools. So let's start there. This is the part everybody likes, right? Let's start with tools. Don't get too comfortable. We're not going to spend a whole lot of time here. I'm going to keep this high level. But basically, we can break it down into, I've got two roads I can take when I'm looking at the infrastructure as code. Option number one, I can start to go provider specific, right? All the major cloud providers offer some level of infrastructure as code support. There's a lot of benefits with this, right? It's all native to the platform. I'm staying in one place. They provide me a service, right? This is infrastructure as code as a service. I don't have the headaches as a member of the team to manage yet another platform to run my IaC on, right? They're providing that to me as a service, as IaC as a service. They're managing that so that I can manage the code for my infrastructure and let it get deployed in a repeatable fashion. And when I say repeatable, there's one thing I want to emphasize. When I say the process is repeatable, and I talked about these new environments, right? Don't get hung up on the fact that it's just because it's repeatable that it's necessarily push button to start creating all these new environments everybody keeps requesting, right? There does require some amount of preparation to go into what it's still going to take to create these. I've got things in our environment like I need to allocate certain IP space from the firm. I need to consider who is this environment going to peer with and how is that going to intercept, right? So I got to load all that information in, and I need to prepare for that before I can set it up to automate for that particular environment. Now, in some simpler cases or in other cases, you can get to that nirvana state of that push button. That's great. You can get to push button, start creating all these new environments on demand. That's awesome. But just set proper expectations with your executives and management and the other teams that are going to consume those environments you're going to create of what that actually takes to do that. Now, all of this comes at a cost, right? If I'm going to go provider specific, these are great benefits. What's the drawback, right? Well, it's locking me into that provider. And that matters more to some than others. In FS, I have clients that are deathly afraid of being locked into one specific provider for one reason or another. Sometimes it's for financial reasons. They don't want to be locked in, right? They don't want to have somebody choking over their neck, right? The other piece is around resiliency, offering a multi-cloud solution. We're hearing this more and more, right? As we go multi-cloud, what does multi-cloud give us in terms of resiliency? Major cloud providers today are not immune to outages, right? There's been very public outages on the major cloud providers. How can we leverage a multi-cloud solution to buy us that resiliency across multiple different clouds? But to do that, now we got to consider option number 2, right? Unless I want to manage my infrastructure as code differently for every single provider, I can go option 2, which is more of an agnostic approach, right? With a more agnostic approach, I have the benefit of not being locked into that specific provider. I can take my solution and my way of thinking and my framework and apply it to multiple different cloud providers and run it even on-prem. I can run that hybrid model that everybody's talking about with hybrid cloud. These kind of tools allow me to do that if I take this road. But it also comes with its own disadvantages that we need to consider. It's an abstraction layer. Things like, if a new product or service becomes available on one of the major cloud providers, and I'm using Terraform, for instance, Terraform is an abstraction layer that helps us out with constructing that. But as that abstraction layer that's built on plugins and modules, that plugin or module may not exist right away for that new product or service that's coming out at a cloud provider, right? So I need to consider that. What does that mean if I need to leverage it? Do I need to look to the community for support? Do I need to build my own support for that module to support it in the interim until something's officially available? So each comes with its own kind of push and pull around pros and cons. So that's as deep as I want to go with tools at this point, right? I just want to make you guys aware that there's 2 different roads I can take. If you want to deep dive into any one of these tools, there's a lot of great vendors out there. There's a lot of other great sessions. What I want to concentrate on is how we effectively use these tools for people and process. And we're going to start with people, the people aspect, right, and culture. This is probably one of the most difficult hurdles for the organizations I've worked with to overcome is the cultural aspect. There's where I've seen this work with infrastructure as code, right, is where this succeeds in their transition is people that have some sort of engineering background. I've seen software developers actually do really well in infrastructure as code. They may not have some of the infrastructure expertise, but their way of thinking around certain pieces, from an engineering aspect and engineering mindset, how do I break these large data sets into smaller modules and reusable components, right? How do I find these repeating patterns and apply my engineering skills towards automating the infrastructure? I've seen them succeed in this area, and it takes that little bit of a mindset. And it shouldn't come as much surprise, right? I mean, we've over the years, we've really matured our methodologies around software development and software delivery, and how can we take that and apply that to our infrastructure that we're delivering today? So basically, we need to start looking at things from an engineering mindset. We're going to break these larger pieces down into modules and reusable components. We're going to share those modules and components across multiple projects and teams. We need to create a culture which is open to experiment and try new things. We need to fail fast. We need to learn from those mistakes, in a blameless way. You're probably looking at me like, these are the things we hear all the time on application development, right? Well, that's kind of the whole point and a theme of this conversation we're going to talk about today is infrastructure as code buys us a means to take all those great principles that we've been honing in on and maturing over the years on our application delivery and take that to our infrastructure delivery that those applications are running on, right? We need to share, we need to collaborate, we need to set best practices. Let me give you a quick example on these quick prototypes and what can we do. I had a client that had a problem set where they needed to look at, as they were moving to the cloud and they were a little immature in the implementation that was there, they needed to look at a couple of key things, which was their resiliency, their scalability, and zero downtime deployments, right? How can we be non-disruptive, but start exploring some of these avenues with the existing applications. We have a number of applications. How can we start to explore how these things are going to run in a containerized environment, right? So we have a proof of concept. How can we take, without being disruptive, the existing flows, containerize the existing images, run those kind of in Kubernetes, start to see them scale and handling the deployments to see how the applications react and start to uncover, hey, you know what, some of these applications that you guys were architecting, when they start connecting to the Kafka nodes and multiple of them are light up and they're not set up to handle that, and then the applications start to fail at scale, those are the things that we identified through a proof of concept just by iterating over 2 weeks, right? And identifying these things quickly and learning from them so we can pivot for the larger term solution. In terms of culture, we also need to consider, how we start to look at other teams and involve people like tech risk, and I mentioned audit before, security firms, right? The concept of shift left, it applied in app dev, we bring QA, further left. From an infrastructure standpoint, what if we start including our tech risk folks and our security folks earlier in the process? I mentioned this before. For us, they're part of our team, right? As part of the team, they're filling in our sprint backlog of user stories. This is the requirement of what we need to implement. This is the acceptance criteria that we expect for that for the security group or whatever that we need to do for the connectivity. We create through the code, we push that through, and they're involved now through the review process to approve those changes based on their acceptance criteria, right? And if we think about that for a minute, from a people perspective, the people that are getting involved now, because of this infrastructure as code and the data model and the way this is expressed, it's actually very human readable to the point where tech risk and everybody else can actually understand the implementation we're doing so that they're comfortable with it and approve that process. I'm no longer, and I mentioned this before, I'm no longer, as tech risk member, signing off on something that's already running. I'm signing off on the implementation of what's about to be deployed. So that brings us to the glue, the process. This is where I'm going to spend most of the time for the rest of the discussion. The process is the glue of how do we take the tools and the people and the culture and put this together to make a cohesive experience. And that's what I want to kind of concentrate on for the rest of this session is how do we put this all together? So I brought this up before. Don't forget about our SDLC, right? Over the years, we've really matured this on the application development side of the house. Our software delivery, what do we do to define that SDLC? Our principles, everything that we apply, we all know the act here of we're going to plan, code, build, test all the way through, right? We're going to have an iterative process to come back, feedback loop, pivot on those changes, and deploy. We need to take these principles now and apply it to our infrastructure, and infrastructure as code allows us a means to do that. As we look at this, we shouldn't be thinking about our infrastructure code any differently now than we do our application code. They're really one and the same. There isn't much that changes between them. All those same principles that we've been doing over the years and honing in on are now going to apply to the infrastructure, not just the applications. So that gets us into becoming more agile, right? Working in shorter iterations. In terms of infrastructure, the one thing that I want to stress here is as we work in shorter iterations, we want to deliver faster. We want to get these changes out the door because we don't want them to pile up. I've had customers that I've gone to that were on quarterly release cycles. And that quarterly release cycle that I went to go look at them with had 40 approvers listed on the change request. And why do they have quarterly releases and 40 approvers? Because everybody was scared and didn't trust the system because everything was manual, right? That's basically what it boils down to. We need to have a standard repeatable process where we're delivering smaller changes more quickly. We're not letting those changes pile up because the more they pile up, they become more risky, right? So what it comes down to is this buys us a means to build trust. We're going to talk about how we introduce toll gates and everything into this in terms of our infrastructure. I've talked about how we involve tech risks throughout the process. They're more comfortable with these changes. The more comfortable they become, the more trusting they become, we get an approved standard change process to get these things out the door quicker. Version controlling everything, all right? This is a given. All of our configuration, again, infra code, no different than the application code. We're going to version control it. But some of the things that I've seen for our clients is, how do we best make use of the version control, whether it comes to applications or infrastructure for that matter. I've seen a lot of companies that maybe migrated from SVN to Git, but then they're just using it as another tool to do the same thing. They're doing everything in Git the same way they're doing in SVN. They're not necessarily leveraging some of the best practices. How do I leverage a branching model to be effective? If I'm going to have all these changes coming in, how am I going to manage that? How am I going to manage my releases? How am I going to have an effective model, whether it's Git flow or trunk-based development, to start monitoring that, getting these changes out the door? I've seen, what we have to consider too is, I mentioned I have 7 different environments. How do 7 different environments, correlate with my source control, right? I've gone to teams that are doing it different ways. I've gone to teams that were, well, we have one repo and then we fork it for each of the other environments. Or I've got one repo and I created a branch for each of my environments. Inevitably, either way, it just becomes a mess to manage. People miss something trying to propagate changes between each of the environments in that manner. Instead, we took a much more simple approach, right? We have a single repo, single source code repo, and our environments are no more than, I have 7 different var files. Those var files include what's the name of my repo, what's the name of my environment, what's the CIDR block range for the VPC that I'm going to construct everything into, who are the peers I'm going to connect with, stuff like that, right? Those are only the unique bits, but the rest of the code base is all the same. Now I've got one code base that gets built and plans out for 7 different environments. Now I'm guaranteed that when I make the change in one place, it's going to propagate to all my environments as I start to promote those pieces. I mentioned this earlier, but we need to support a modular component-driven design as it applies to our infrastructure, right? We need to identify repeating patterns and opportunities for improvement and consider how those components can be shared across multiple projects. I'll give you guys a quick example. With our project, I mentioned peering connections a couple times, and we got tons of peering connections. We got all sorts of shared services we need to connect to within our platform. And the infrastructure as code is great. It gives me an easy way to define these things, but maybe it takes me half a dozen different resources, right? I have half a dozen different resources to define my peering connection and what's required. And I've got multiple different peering connections I need to go to. Now I'm finding myself copying and pasting 6 blocks of code 7 times over for all these different environments. We need to look for the opportunities there where there's these copy and paste situations, start to drive these into reusable components, right? Because ultimately, maybe I have to solve that problem for my project, others need to solve it for their project in the same way. Maybe when I need to make a change to that, I don't want to have to make a change in 50 different places. I want to make the change in one place and have it replicate everywhere, right? So we need to think about that. How do we take those identify those repeating patterns and start to abstract them out to reusable components? We leverage code reviews. I mentioned this before as well, right? Infra code, no different than our application code. It goes through the same repositories. We're going to make the same kind of pull requests. And on those pull requests, I'm going to include people. But who we're including is not just our peers or our tech lead. We're also including tech risk. This is their sign-off period from a risk standpoint, right? If tech risk came in with a user story that says this needs to be implemented this way, this is the acceptance criteria, this is their opportunity to review that code change, right? They're involved in that process. They can see the code change. Not only can they see that code change, but they can see the plan of how that code change is going to result in terms of a plan for each of those 7 environments. And remember when I mentioned the cultural aspect, right? There's a learning curve. As companies start to adopt these infrastructure as code principles and whatever that platform is or that framework, the code reviews are a great way to share that information. Everybody's going to approach something a little bit differently, especially when everybody's kind of learning and starting to take on some of these things. Having multiple people involved in the code review process, just so they're understanding how people approach different solutions, is extremely helpful in kind of organically growing the team. So I mentioned before on that code review, right? They're not just reviewing the code, but these plans. What are these plans I'm talking about? How do these plans get there? Well, of course, we have to have some sort of CI/CD pipeline for our infrastructure, just like we do our applications. These things need to trigger, on commit, on a pull request. And for us, this all starts with the pull request, right? When a pull request comes through, We're going to take that code change, and we're going to run it through our pipeline. And the first thing our pipeline is going to do is it's going to plan out that code change for all 7 environments. I'm going to end up with a plan for each of the 7 environments that's attached to the pull request. So now when I'm reviewing the code, I can actually review, this is what the system says it's going to do to implement that code to all the systems. I can say, in this particular plan, it's going to create this resource, it's going to delete this resource, and it's going to modify this resource, right? I can actually see it, how it's going to lay out and execute in each of my environments and use that as part of my criteria for accepting that pull request. But in addition, as part of a pipeline, right, I can start to introduce certain things like policy checks. These policy checks on the infrastructure allow us to give us an automated pass-fail based on certain conditions. Those conditions become our toll gates, right? So our policy, how we enforce different policies. These are things like, for our case, right? If I push through a change and I put out a new storage volume that's going to be attached to one of my VMs, was that storage volume encrypted? Because as a security standard, we need to make sure all of our volumes are encrypted. Our policy check can catch on that and tell me if I forgot to set that. If I modified a security group, did that modification to that security group just leave us open to ingress and egress from the public internet? The security policy will check on these things. Again, these are another way for automation to help us in terms of building up that confidence in what our change is going to introduce into those running environments before we actually deploy them, right? This is how we build that trust with everybody to get these changes out the door quicker. So that kind of gets us into this automated testing. This gives us a means to start automated testing of not just these policies, but we also need to consider, with this, can we start to test the creation and destruction of these environments, right? Let me give you a lesson learned from us, and I've seen this laid out in multiple different infrastructure as code projects. Everybody inevitably runs into this issue. You may have been running this project for months, maybe more, right? You make a change at some point in time. You make a change at some point in time right now, you deploy it now, and it works right now on those existing infrastructure. What you didn't realize is your change inherently had an indirect dependency on something else, right, in the whole big plan, but that piece of the plan had already run because we've been running this project for months, right? And I didn't realize that. Let's think about it in terms of a linear flow. Let's say I have 10 steps in my plan. At some point in time, I'm going to change step number 3 and add step 3.1. If I apply 3.1 right now, it might work on that target because step number 10 was already applied sometime in the past, and it didn't need to reapply it. So when I introduced step 3.1, maybe it worked because 10 was already applied, and I didn't realize that what I was trying to do with step 3.1 depended on 10. So when I try to run this plan now, I'm going to create a whole new environment, maybe several months down the road. All of a sudden, my plan starts to fail because I had an unknown dependency. Now, some of these frameworks have a built-in means to do that dependency tracking, right, and help us with that. But that's not always the case. There's certain gotchas, you might miss these things. So this is a great way to uncover these things early, right? If I can allocate space to, on my pull request, stand up the entire, a brand new environment and then tear the whole thing back down, that allows me to identify these things quicker. It also allows me to start looking at how does my change affect applications that will run in my environment, right? I might be able to, within that new environment I create, spawn the applications to run in them and check the health state of those applications. Did that security group change I just made cause a breaking change to one of the applications and no longer connect to one of its services, right? I can get that information live before I deploy it in one of the environments. So I want to come back now and talk a little bit about working in teams. For us, I mentioned before, we had a very small team of 3 that were managing these 7 different environments, 7,000 resources, right? But we were just one smaller team and a larger team, right? We're managing one single platform that's but of a cog in a bigger machine. And all these teams are working on different bits and pieces, different platforms that all integrate and touch in some way, shape, or form. And everybody may have their own project that they're managing for each of these pieces. And what we need to consider when we're working in these teams and these larger projects like this is what are those intersecting points between those teams and in those projects? Inevitably, there might be some shared resources, and these are the things that we ran into, right? We're both trying to manage the same resources. Maybe I need to add a security group rule here or a routing table here, and we're both trying to manage or touch the same thing. And what happens when we collide, right? Sometimes with infrastructure as code, you can approach things different ways. I can take a resource like a security group, right? To each resource, think of it as a parent and child relationship, right? The parent is a security group. The child is that security group has a bunch of rules, right? I can look at it as one big thing. I can manage the entire security group and inherently its children, or I can treat them all as different things. I can manage the security group, but then I manage the children of it separately as individual rules with a relationship to that parent. And that was something that we experienced, right? We had set it up as the latter, where I'm just going to manage the children that I'm going to associate with the parent. But another team had taken the other approach and tried to manage the parent. So what happens is we deploy our changes, we're all up and running. They deploy their changes, and because they manage the parent, they blow away all the children, make a new parent with their children that doesn't contain ours, right? So we need to figure out how, when we're touching these shared resources and these same pieces, how do we intersect, how do we work together to avoid these kind of pitfalls, right? So I went through a lot here, went through it a little too quickly. But let's take a step back and take away, what are some of the key takeaways we can take out of this and bring back home with us? We're going to do this in kind of the do's and the don'ts, right? Number one, we want to leverage infrastructure as code to keep our environments repeatable and consistent, right? To do that, we need to involve our business, the business users, the security users, our tech risk teams to establish a standard repeatable process. That's the only way that this is going to work and to get changes out the door quickly and not get locked up in these quarterly changes with these long CRs and 40 approvers, right? We need to have a standard repeatable change. You need to build the trust factor with the groups to show we have a repeatable process in place that guarantees all these tolls are going to be met, right? These toll gates and these conditions. We need to version control everything. All of our code needs to be version controlled. We need to have a branching model around all these pieces just like we do for our applications. We need to continuously monitor those systems, these processes. We need to get faster feedback and enforce that confidence and the agility in making these changes without error. We need to push in small changes in small chunks. Again, the only way we're going to do that, we can't stack up these changes. When these changes stack up, it becomes more difficult to manage. I talked a lot about these plans, right? These plans, every time I make a code change, it's going to make a plan of what it's going to execute in that environment to make that change. The problem I've seen is if people start stacking these things up, they're merging them in, they're stacking them up. Ultimately, what happens if I'm not releasing all these changes out and letting them go, the plans just keep getting bigger and bigger every time somebody makes a change, right? Somebody makes a change, and in me as a pull request, reviewing a pull request, they're just making one small little change. I'm expecting to see the plan that only has one change in it, and all of a sudden the plan has 40 different changes. And those 40 changes are because of all the other things that were accepted and merged back into master that haven't been applied yet because they're all stuck up in the queue, right? So these are the things that we need to watch out for so we can deliver quicker. We need to automate that deployment with the health checks that we talked about, having the cutovers, the rollback mechanism for the environments. And we need to consider what are the required capabilities that we're looking at and how do we enable the people, processes, and tools to support those in a DevOps culture. And I think the last thing I want to leave everybody with, I've been emphasizing, it was the theme of this whole thing, right, is we as an industry have been doing very well at maturing our application development and deployment and delivery process. We need to take infrastructure now, and infrastructure as code gives us the means to take all those great principles and everything that we've been doing and now apply that to the operations side within the infrastructure that those applications are running on. So with that, I thank you. Again, I'm Jeff. I'm with KPMG. We have a booth outside at 10:13. If you want to talk to us more, we'd be happy to discuss. Also, we are actively hiring. If there's any engineers looking for a career change in different fields, we'd be happy to talk to you. Anybody with agile practice experience, anybody that that leads in digital business transformations, we'd be happy to talk to you. So take a couple questions too if you like. Takers? Boy, you're quiet. All right, thank you.
How do you typically manage change across environments like staging, production, that sort of thing?
Sure. So what we typically do is we have, within our change process, when we merge a change into master, right? As I noted before, at that point, or I should say before we even merge into master, the pull request itself will give us what the tentative plan would be for each of the environments. So we can sign off on the change of what would be tentatively planned for all those environments before we merge it into master. Once we merge it into master at that point, it starts a propagation sequence. So we have different, like our first environment is called sandbox. From sandbox, this is just internal for us to muck with. That doesn't affect our app dev teams or anybody else. So we'll go through, we'll deploy, run all of our tests, and make sure everything is solid. And then we can, at that point, once it succeeds and passes at that point, it goes to the next stage, and it goes to the next environment. And we have a promotion process that allows us to monitor that and do it one at a time. So that way, if there happens to be an issue applying that plan, even though the plan was great, when it goes to apply, there could have been an issue. I'll give you a quick example where things have gone awry. The plan might be fine. The plan's going to be like, I want to add these new VMs, right, of this specific type. And the plan says, I'm going to create these new VMs of the type you requested. Awesome. I'm on a cloud provider. It's going to go do that. When it goes to apply the plan, things go awry. It breaks down. Why did it break down? Turns out the cloud provider didn't have enough instance types in the AZ that we were trying to load this into, right, to support that. But there was no way for our plan to know that ahead of time. Or it may have been our internal limit, like we hit our internal limit for the number of that instance types that we could have in that region. So we need to go and extend that limit. So it may have been something on our side, it could have been something on the cloud provider side, they just didn't have enough instances for that. We've run into these things. So this is the means where the plan can take you so far. When you go to apply it, there's certain gotchas. So this gives us a means to stop the process and fix it and correct before we start to propagate it to the other environments. But yes, that is another workflow that monitors the progression of deploying it between each of those environments and making it up to the next.
In your experience, is the addition of modules, like encapsulating that functionality in modules, that make it easier or harder to propagate those changes through different environments?
Well, I mean, it definitely makes it easier from the implementation standpoint. From the way the plan and the apply goes, it really doesn't change anything, right? It just makes it easier for me to make the code change, and I only have to make it in one place. But from an Assura side, like I know that it's going to replicate to all the places leveraging that module. Mm-hmm. Anyone else? Yep.
One of the slides mentioned about testing the changes in your infrastructure. How do you test the code written for provisioning the infrastructure?
You can write functional tests around certain expectations.
We have some automation based on enhancement, and you write bunch of playbooks to configure some nodes, and you want to test the changes in your playbooks.
Yep.
Or you want to test the target.
I mean, it depends on the change you're employing, right? But you can write a functional test or an end-to-end test of the change that you're implying, right? So with that change, I can write a functional test to verify the change that I'm making. If I'm making a change to a security group, can I write a test that can verify that connectivity at that point? If the test is, hey, the current state of this application is failing, can I run that application with this change and get back the health check from that application that all the applications are at a correct health state, right? There's different means we can do to do that. Yep. Yeah. Sure. So I think it ultimately comes down to, I noted before where I've seen people with an engineering background do very well in here, and sometimes I've run into clients where there's been people operating these environments and running these different infrastructure pieces that didn't necessarily have an engineering background, which had more trouble, coming up with some of these solutions or grasping some of the concepts, but pairing them and doing things like, paired programming and stuff like that, and interjecting the team with people, even from app dev. I've seen that come over. Like, there's a crossover, right, to help and train and help to take some of the principles and approaches and allowing them to pair and effectively do that, right? That's a way to grow those teams and interject them that way. Yes?
Did you upgrade to 0 that 12 yet?
How did you know I was on Terraform? No. Tried to avoid, yes, we have not gone to 0.12 yet. That is on our roadmap. I think we're on 13 or 11.13, 11.14, 11.14. Sneaky. You're going to make my risk guys have a heart attack over there. Can't mention names. Anybody else? Yes?
So KPMG said you have customers, so you offer consulting services in this space. Is that kind of the group you work for? Is that?
Yep. Yeah, so we have many different, within the firm, we have many different people that specialize in different areas. We come out of digital enablement. Our group grew out of, we used to be like a small boutique. We did a lot of application development. We did the strategy, design, delivery around applications. That's where we kind of came out of, and we were acquired by KPMG several years ago. But we've grown over the years. We have many different segments. We've got an entire piece just on cybersecurity. We've got a whole function around CIO advisory. We've got many different fashions that all kind of come together. We take bits and pieces from different teams to provide a holistic solution.
Just a follow-up question. Have you ever heard within your practices of infrastructure as code for things that are so physical? I'm kind of an anomaly here. I think that my role in a manufacturing company
Okay.
is networks and physical networks. When you think of anything that can't be in the cloud, that's kind of my domain.
Got it.
So think about your routers, your firewalls, anything that's on-prem.
If it's on-prem and it's something like with VMware, vSphere, or something like that, then yeah.
Think everything that is not compute.
Yeah.
Think of
Yeah.
everything that you connect your access point to, your IoT device, manufacturing plants, your robot.
Wow. That's a great question and a great problem space. I unfortunately don't have a lot of experience in that, but that's actually kind of interesting how that would apply.
Yeah, and that's why I'm asking if within your organization you've ever heard of customers needing that kind of thing.
I can definitely check. If you want to follow up with me afterwards, we can have a discussion. Thanks. Yep. Anyone else? I'll bid you adieu. Thank you.